Okay, hi everyone. Today I'm going to give you a deeper understanding of drawing curly arrows in organic chem. So when you draw an arrow, there's always a tail and a head. So it looks something like this. There's a tail and a head, right? So that's how you draw it. Okay, so it's actually drawing arrows actually shows the movement of electrons. Okay, shows the movement of electrons from one side to another. So there are three classes of reaction arrows. One shows a lone pair becoming a bond pair. Another one is a bond pair becoming a lone pair. And the last one is a bond pair becoming a bond pair. So but there isn't any one that shows a lone pair becoming a lone pair, right? So the tail is the electron donor, right? So that's where it gives the electrons. And the head is actually an electron acceptor, right? The head is the electron acceptor. Okay, so normally what we do is this. So for example, right? So let me just give a simple example, right? When I draw an arrow showing the lone pair goes to Y, so this is what happens. So I'm going to just give a bit of a color, all right? Two dots, right? Those are the lone pair on X. So we say that the formal charge of X is 0 at first, right? There's no charge, so 0. So when X give electrons to Y, right? When X give electrons to Y like this, in fact the lone pair becomes like this, right? So generally you can see that X actually given almost like you can say that X has given this red electron to Y. So we say that the formal charge of X would actually be increased by 1. All right, will actually become more positive. So the formal charge of X now becomes plus 1. Okay, and we take it as Y have actually gained 1 electron. So the formal charge of Y has changed from 0, at first was no charge, and then became minus 1. Okay, became actually minus 1 because it's almost like as if it's gained 1 electron. So normally that's what we do when a pair of electrons being donated from the tail, the atom from this side will have a formal loss of 1 electron, making its charge become more positive by 1. So that's why I said from 0 becomes plus 1. And for Y, right, for Y, the original, we take the formal charge to be 0 at first. So once it gains, like as if it gains 1 electron, it changes from 0 to minus 1. Okay, so when a pair of electrons being accepted by the head, right, by Y in this case, this side will have a formal gain of 1 electron, and you can see that the formal charge will actually increase to minus 1, from 0 to minus 1. Okay, so let's give you some example. Right, so let's look at the first example here. Okay, let's look at the first example. Okay, when a lone pair becoming a bond pair. Let's look at this example. So OH minus, can you see that the minus, the lone pair, it gives to a H, which is H plus. All right. So firstly, for organic chem, we must be able to see what bonds are broken or what bonds are formed. In this case, actually, you're only forming an OH bond, right? You're only forming an OH bond. So in this case, actually, when the electrons, the lone pair, okay, the lone pair moves to the H, all right, moves to the H. In fact, this is the bond that's being formed. Can you see that? Okay, so actually, this is the idea of a lone pair becoming a bond pair, right? You can see a lone pair becoming a bond pair. And O from a charge of, say, a minus 1 formal charge, all right? So after giving that 1 electron, it has no more charge. Can you see that? So it's almost like neutral. Okay, H from a plus, we take it at, it has like more or less like gain 1 electron, right? Gain 1 electron. So from plus, all right, plus 1, it becomes 0. Okay, so that's why you can see there's actually no charge on H. Are you me? Okay, let's try another example. So the next example I'm going to go through is actually bond pair becoming lone pair. You can see that this is a bond pair, and oxygen being more electronegative, the electrons will go to the O. All right, so the bond will break. Okay, so the bond pair now has become a lone pair. Is that a bond pair has become a lone pair? At first, oxygen has a formal charge of 0, which means that it doesn't have any charge. I mean, it doesn't really have any charge like 0, right? So, but now it becomes minus 1. Can you see? Minus 1. Okay, 0 to 1, because it actually sort of like gain an electron. Okay, it's sort of like gain electron. At the same time, H, the formal charge is 0. But now, since it has lost like 1 electron, right? So that's why it become a plus. Alright, but more importantly, I want you to be able to see that in this movement electron, a bond pair has become a lone pair, right? Can you see that? a bond pair has become a lone pair. So this is the second example. Okay, last example, bond pair becoming a bond pair. So in this example, you can see that the bond pair over here, all right, the pi bond over here has become this bond over here. All right, so a bond pair has become a bond pair. So in fact, the electrons has moved to the H. So you can imagine what you can imagine is like this, right? You can take it as that line that sigma bond has moved here, all right? So H has more or less like gain an electron, right? Gain electron. So the former charge from +1 becomes 0. Okay, former charge from +1 became 0. And in fact, this carbon here, okay, this carbon here, the former charge was first 0, but it's now more or less like lost electron. Okay, so it becomes a plus. Can you see that? It becomes a plus. So in fact, this carbon here that I'm going to highlight, actually there's no change in the former charge of this carbon, because you can see that the bond has just moved from CC bond to CH bond. So this carbon here, there's actually no real gain or lost electron, so that's why there's no change in the former charge. So this shows actually bond pair becoming bond pair. Right, so I'm going to give you a few more examples to make it a bit clearer. Right, so anyway, more importantly, you must be able to see these are the only three ways of drawing arrows: lone pair to bond pair, or bond pair to lone pair, or bond pair to bond pair. Okay, no lone pair to lone pair. Okay, now let us look at questions that have more than one curly arrow, right? And how will the charges change, right? So no matter how many arrows you draw in sequence, right, you only change two charges, right? You only change two charges really, right? And what are the charges that you change? You only change the initial, I say the initial tail and the final hit, right? The initial tail and the final hit. So let's go through one example over here. Okay, so before even you do it, you must be able to understand what bonds are being formed and what bonds are being broken, okay? So for this example, I hope you can tell that the OH bond here is actually being formed and the HCl bond is actually being broken. Can you see that? So let's try to draw the arrows then. Okay, so the lone pair and the O, anyway, you should know that Cl is delta minus and H is delta plus, right? So the O will join to the H. So you're going to draw the arrow, right, from the lone pair and the O to the H. Can you see that? And then the HCl bond is broken. You need to draw another arrow to the Cl. Okay, so you can see that the lone pair becoming the lone pair O, right? Okay, became a bond pair. Can you see that? It became a bond pair. So lone pair become bond pair. And this one, the bond pair on the HCl became a lone pair on the Cl. Right, so it fits the rule. Okay, how about the former charges, right? Former charges. So O actually has a minus charge at this point in time, right? In the initial is minus. Okay, so once it loses electrons, so -1 will become 0. Okay, so that's why you can see that this oxygen doesn't have any more charge. Okay, and I told you, right, the thing is this. They say you only change the charges at the initial tail, highlight the initial tail and the final hit. So what I'm trying to show you, you only change the charges at the O and the Cl, the initial tail and the final hit. Okay, so in fact, nothing happens, no changes in the H. You know why? You can see from the H, right? H over here actually gained electron and then it lost electron. Okay, so there's no real change in the charge of H. So O from former charge of -1 became 0. And Cl, right? Cl, you can see that from 0 becomes, gain electron become -1. So that's why there's a minus on the Cl. Okay, let's try what happens if there are 3 arrows. Okay, so maybe I just finalize this. For oxygen, right? Put from -1 to 0. And the final hit for chlorine from 0 to -1. Can you see that? Okay, now let's look at a question like the one with 3 arrows, right? Let's look at the next example. Okay, so firstly, you must be able to see where are the bonds that are being broken and where are the bonds being formed. So I can see that over here, this bond is being formed, right? And this bond also being formed, okay? And I can see that the bond here being broken and this bond being broken. Okay, maybe I use a different color, right? This broken and this is broken, okay? So let me draw out. Okay, so you must be able to see, okay, you're going to form this bond, the OC bond here. We're going to form this bond first, okay? Yeah, so I'm going to draw this arrow going here. So maybe let me try to show you what's really happening step by step. So in fact, when O goes to carbon, it forms a bond with the carbon. All right. So this bond is being broken, right? So you have to draw an arrow here. Okay. So let's just do this. Okay, draw arrow here. Why there? Because this bond is being formed. You see, one bond is being formed here. So no more double bond, single bond, but this will be a double bond. Right, this part will be a double bond. And this one that's being broken, the CCl bond being broken. If you can see here, this is the bond that's being broken. This one being broken, and you can see that Cl being more electronegative, of course, the electrons will go to the Cl. Okay, so I don't have to draw anything. So you can see I have three arrows, and where are the changes in the charges, right? The real change in the charges actually lies here. Okay, lies here. It lies on this O, because this is the initial tail and the final head. Okay, everything else remains the same. So the O, after giving electrons, you will see that it becomes a plus, right? So you can see that this is the initial tail from 0 to plus 1, right? And the final for Cl, 0 to what? Minus 1. Can you see that? So that's why you can see there's a minus on this Cl, all right, and you can see there's a plus on this O. Okay, so plus Cl minus, of course. Okay, so the oxygen from 0 to become plus 1, and from the Cl from 0 to become minus 1. So that's how it tells. So everything you can see from here, like this part, lone pair becoming bond pair. Okay, becoming bond pair. You can see lone pair becoming bond pair. This one from use red. This is what? Bond pair becoming bond pair. Alright, and this one, last part, it's a different color. This one, can you see this is bond pair actually becoming lone pair. In fact, it's I should draw the dots, right? So actually it's like that. Okay, becoming lone pair. Okay, bond pair become lone pair. Alright, so this will hopefully gives you some idea of arrow drawing. Okay, let's move on and try the next example. Okay, so maybe just to give you an idea from the mechanism that we learned in school. Okay, so let's try the first one, electrophilic addition. I think most of you should be quite familiar with electrophilic addition. So we know that the pi bond actually polarizes the Br, the pi bond polarizes the Br molecule such that it will have a delta minus and a delta plus over here. All right. So you can see that the first arrow, so this Br delta plus, right, is gonna try to accept the electrons from the pi bond. All right. This Br delta plus is what I call the electrophile. Okay. So this is how you draw it. So this pi bond will go to this Br. Can you see that? And this bond here will go to the Br. All right. So become a lone pair. So let's try to see what's happening. So the pi bonds, all right, goes to the Br. In fact, you're forming this. So the first example is a bond pair to a bond pair. Okay, a bond pair to a bond pair. And you realize that in fact, this carbon, maybe if I highlight, this carbon here, okay, it is the one that's probably have sort of like lost the electron. Okay, so the formal charge of O over here, of this carbon, sorry, the formal charge of this carbon actually we take it as 0, but since it has lost an electron, right, so now that's why it becomes a plus. All right, so actually it's this carbon actually 0 to plus 1. Can you see that? Okay, we're not being bothered about this Br, right? This is the middle one. We don't care. The only change in the charge will be the last one here, Br. Okay, this Br actually have a formal charge of 0 first. All right, so but now since it's gain electron, now the formal charge here is a minus. Can you see that? All right. Okay, let's look at the step 2. Okay, so Br minus and a carbocation. That's where the carbocation will accept the lone pair. So when you draw this to form a bond, right? So you can see this Br from a minus, okay, there will be an increase in 1. So minus increase in 1, so minus 1 to become 0. So there's no charge on this Br, notice. And carbon, which is actually more or less a gain electron. So from plus 1, you decrease by 1, becomes 0. Okay, so that's why this carbon doesn't have any charge anymore. Can you see that? Okay, so this is the idea, very important, right? So you can see that when you draw an arrow, the tail will become more positive by 1 and the head will become more negative by 1. Right? Okay, so let's try one more example. So I'm just trying to relate back to what we learned in the examples that we've learned in schools. All right. Okay, let's look at the next one. This is electrophilic substitution. Okay, maybe I just go through this arrow drawing. Okay, I'm going to show you this arrow drawing. So the pi electron cloud from the benzene ring will go to the Cl plus. In fact, this is what's really happening. All right, we know that benzene ring actually is like there's 3 pi bonds inside here. Okay, so if I do it this way, what's really happening is this. Okay, but of course there's resonance, but just to show you this idea. So over here, the electrons pi bond go to the Cl, right? Okay, so I want you to take note. Look at if I have to draw it out this way, you realize that this blue line, this line that I've just drawn, okay, this green line, sorry, this green line, the electrons bond pair become a bond pair. So actually from there actually became this one here. Okay, so this is actually bond pair becoming bond pair. So it will actually be like this. Okay, so I'm going to use the same green line. Okay, put it here, and this is my Cl. Can you see that? All right. In fact, the carbon, so the Cl from a plus, can you see that? From a plus 1, so gain electron becomes 0. So Cl doesn't have any charge anymore. Okay, if you look at this carbon here, okay, if you study this carbon here, let's look at this carbon over here that I'm talking about. In fact, this carbon, the former charge was 0 at first. Okay, this is where the tail is starting from. The tail is starting from. So at first the 0 has a former charge of 0, but now since it's lost electron, that's why this carbon now will have a former charge of plus. Can you see that? But of course, there's this thing called resonance, right? It's resonance. So not to waste too much time, but this plus can actually it will spread out and within the entire benzene ring. So normally we draw like this. Okay, so how it works is, okay, just to give a rough idea. Okay, this bond pair will actually move here. So I'm going to just draw a bit of a resonance for you. Right, this is a bit more info already, but it's okay. All right, so the electrons will be drawn towards the carbocation there, and in fact you will see this happening. Right now the Cl is over here, and there's a pi bond here, and there's a pi bond here, and this carbon here will become a plus. All right, and then the last part is there's another movement electron like that, because the pi bond will go to the place that is carbon. This carbon is electron deficient, so I can draw it this way. Right, and this carbon will become a plus. But I'm just trying to show you this whole structure is what I call resonance. All right, so we actually draw it like that. Okay, with we actually draw it like this. Okay, so this is a resonance structure. That's how we draw it. Okay, the plus is actually spread out throughout the entire benzene ring. Okay, so that's what we draw. Okay, you can see that the plus could actually be on this carbon or this carbon or this carbon here. Right, but okay, sidetracking. Okay, let's look at the next part here. Okay, for nucleophilic substitution, all right, the C is delta plus, is the CBr bond is a polar bond. So Cn minus is your nucleophile, right? So the lone pair on C, right, this is the tail and it will tag the carbon, right? So, okay, and then when that happens, the electrons will go to the Br. Okay, the formal charges only changes, I told you, for the initial tail and the final head, right? So you notice what's happening. The Br from a formal charge of 0, so gain electron become -1. So that's why you can see the Br is actually -1. This carbon, right? This carbon here, there's a minus, so -1. So once it gave away electrons, it becomes 0. So that's why there's no charge on the carbon here. You can see that? There's no charge on the carbon. Okay, let's look at the next example. Okay, so let's look at for ammonia. What if ammonia was the nucleophile? Alright, so same concept. Okay, so N will attack the carbon and electrons will go to the Br because the Br is electronegative, it will pull away the electrons. So the only change in the formal charge will be the N and the Br. Notice? Okay, that's the beginning, the initial tail, and the final head. So if you look at it carefully, Br again, same, 0, formal charge 0. No means you don't write any charge on the Br. So now, since the gain electron become -1, so you can see that this Br is minus. And for nitrogen, at first it has no charge, so I say it's 0. Okay, no charge, no formal charge. So don't get mistaken, it's not oxidation state, it's no formal charge, 0. So once you lose electron, all right, it becomes +1. So you can see that's why I put a plus on the nitrogen. Get me? All right, so but this after that, this ammonia will pull out the H plus because it's a base, and this part is like an acid, so it's just an acid-base reaction. All right, pulling out the H plus from NH3 plus. All right, but that's not my concern for this. Okay, let's look at the next part. Okay, nucleophilic addition. So I'm just going through the mechanism that you have learned, so to put things into perspective. All right. Okay. So very quickly, next one, lone pair. All right. So this is the initial. This is the initial. This is the what I call the initial tail, and this is the final hit. Correct. That's why we always draw. Okay. If you notice, okay, just look at what's happening. This is a lone pair. So when I attack this carbon, so lone pair became bond pair. Can you see? Lone pair became bond pair. This is the bond pair I'm talking about. Okay, in fact, this one is a bond pair. So once electrons go to the oxygen, in fact, there's a dot here. So now the bond pair becomes a lone pair. And you notice this O. Okay, let's try again. This O have a formal charge of 0. So once it gains the electron, we say it becomes -1. Okay, so that's why you see a minus on this O. For the Cn minus, right? So from -1, so once it like give electron, so it will actually become 0. So there's actually no more charge on this carbon. Okay, so that's how it works. All right, so you only consider the changing of the charge is only for the initial tail and the final hit. All right, final hit. Okay, Ken, maybe you do one more. Okay, so lone pair. Okay, this one attack the H, right? So lone pair become bond pair. In fact, this is the bond that's being formed. Okay, lone pair become bond pair, and this one is bond pair become lone pair. In fact, that's where the lone pair is. Right, that's where the lone pair is. Okay. Okay, in terms of the formal charges, so -1 becomes 0. So there's actually no more charge on the O. All right, and the final hit here. So C, right? C from 0, give no formal charge there. Gain electron become -1. So that's why you can see it's Cn minus. All right, all right. Okay, so that's how we look at it. Okay, just to give a bit more meaning to arrow drawing. Okay, so we are more or less done. Okay, we'll try one example over here. Okay, so when one thing you have to do when you do all this arrow drawing, right? Sometimes you have to ask yourself, what bonds are broken and what bonds are formed. Okay, this will give you a better idea of what's happening. So let's look at this example. This is base hydrolysis of ester. Okay, this is base hydrolysis of ester. If you look at it carefully, I want you to be able to see what bonds are broken and what bonds are formed. So look at step 1. Step 1, I can see that this bond is being formed. Can you see that? This bond is being formed. And I also can see that, in fact, this bond is being broken. Okay, this one I highlighted is being broken. So you need to know what bond is being formed and what bond is broken. So this is actually delta minus, this delta minus, and this carbon is delta plus. All right. Okay. So what happens is the OH minus will be the nucleophile. All right. So it will, since they're gonna form this bond, right? So you're gonna attack this carbon. Okay. And the second arrow is because carbon, you cannot have like 5 bonds, right? So one bond must be broken. And I already highlighted the bond that's broken. It has to go to the O. Okay, so that anyway, O is very electronegative. It will pull away the electrons. So you can see a lone pair has become a bond pair. Am I right? And a bond pair has become a lone pair. Can you see that? Right. So this is exactly what's happening. Okay. How about looking at the change in the formal charges of the atoms? All right. Let's look at the change in formal charges of the atoms. Okay. So let me just take away this so that it makes it a bit easier. All right. So the change in the formal charges will be on this O and on this O, isn't it? I told you the initial tail and the final hit. So for O minus, all right, O minus right over here. So you can see that it's as if like the oxygen from -1, since giving electrons away, so it becomes 0. So you can see that there's no more charge on the O. And the final hit, right? You can see the final hit, okay, for this one. the final hit, oxygen at first has a formal charge of 0, so now become -1. So that's why you see a minus over here. Okay, so that's how you do your arrow drawing. Okay, I hope this makes a bit more sense, right? So this is what you get. Okay, let's look at step 2. Okay, step 2, you must be able to see what bond was broken and what bond was formed. So this is a very, very important concept when you do organic chem. Which bonds are broken and which bonds are formed. Because if you can't see that, you're going to get stuck. So over here, look at the next step, right? Look at it carefully. You must know what bond is being broken and what bond is being formed. Okay, I can see that this bond is being broken. Can you see that? Right, this bond is being broken. And I also can see that this bond is being formed. Alright, okay, so all the arrows have to deal with on the two highlighted ones, okay? So you can see this RO minus. Okay, so I can go to draw it out now. You can see that I'm going to draw this arrow. The electrons will go to the O, alright, because I know that bond is being broken. And so this actually is a bond pair becoming a lone pair. Okay, there's a lone pair and an O now. Alright, bond pair become lone pair. Okay, for the next one, the bond that's being formed over here, right? This bond that's being formed over here is actually the lone pair is going to become a bond pair. Alright, lone pair becoming a bond pair. And I like what I mentioned again, the formal charges only changes, alright, at the initial tail and the final hit. Alright, so O minus, you can imagine O minus, right, from -1. So once like it has like given away electron, it becomes 0. And this O here, the final hit, right, from 0 becomes -1. Okay, so you can see that it's minus here. Alright, and this O doesn't have any more minus charge. Okay, so that's how it goes. Okay, the last step. Okay, so I think you should be quite comfortable doing the last one. Okay, so you must firstly ask yourself what bonds are being broken and what bonds are being formed. I guess you can see that this bond is being broken. And in fact, okay, I'm going to just show you this. Actually, I will just do it this way. It's an OH. So you can see that this bond is being formed. Right, this bond is being formed here. Okay, maybe I should. Sorry. Okay, so this bond is actually being formed. This bond. Okay, I'm just going to highlight. Okay, this bond is being formed. Okay, so hopefully you can tell the first bond that is being broken. Okay, the bond that is being broken, let me just draw it up. Okay, this bond is being broken. You see there's O minus, right? So you must be able to see that the electrons goes to the O. Can see that? And then you form a OH bond. So this O must attack this H. Alright, so the formal charges only changes at the initial what? Initial tail and the final hit. Okay, so you can see that the O here from an initial formal charge of 0, it becomes -1. And for this O minus, right, the initial -1, okay, has become, because loose electron, right, becomes 0. So that you can see that this O now doesn't have anything and no charge, and this O is an O minus. Alright, so this gives you a good idea of how you tell, okay? So just this whole exercise basically let you see things in a slightly different light. Okay, now I'm going to give you some practices. All right, let's look at this slide here. Maybe at this point in time, you can actually pause the video and look at this slide here and try to do the questions. All right, try to do the questions, and once you're done, you can compare your answers with mine. All right, so take a minute and pause this video. All right, pause this video now and try to do these questions. Okay, let me run through now. All right, let me run through now. I'm just going to highlight the bonds. So when we do that question, all right, I hope you're done already. So when we do that questions, we have to look at what bonds are being formed and what bonds are being broken. They'll give you a very rough, good idea how you draw your arrows. Okay, so let's try this example. So you must see for example number 1. If you notice over here, all right, it's actually like that. Okay, so in fact, there's a extra bond that's being formed over here. All right, this is the bond that's being formed. Can you see that? So so the O now is joined to this H. So actually, I will have actually drawn like that. There's a lone pair and the O. It will move to the H. Okay, that's how you draw it. So the H will have now no more charge, but the O will be +1, as you can see. Okay, let's look at next one. The next one, you can see, you must be able to see that the bond is being broken. In this case, is just this one, right? That's the bond that's being broken. So always look at what bond is broken and what bond is formed. So in this case, I'll draw the electrons going to the O. Okay, so in fact, yeah, so now O will have no formal charge, and then the carbon, the initial carbon here will have a plus. Can you see that? Right, so that's the arrow that you should be drawing. Okay, the next one. Okay, what bond is being broken here? Okay, I can see that over here. Maybe I have to draw it out nicely so that maybe somebody can tell. In fact, there's a H here, right? And there's a H over here. So you must be able to see that, in fact, this H is being broken. Okay, this CH bond is being broken. All right, and after that, over here, you, in fact, when you draw H3O plus, right? H3O plus is like this. All right, so what bond is being formed? The bond that's being formed is the OH bond. And the OH bond. So I'm just going to draw it out now, how you should see. And another bond that's being formed, I forgot to say, another bond is being formed is the pi bond here. Okay, the pi bond is being formed here. So hopefully you must be able to tell that it looks like that, right? So the pi bond, the sigma, this bond pair will become a bond pair. Okay, bond pair become a bond pair. And then this O, right, I'll draw the arrow pointing to this H. Okay, so that's why you get H2 plus. So you notice that the plus is on the O, all right, and okay, because that is the initial tail, and the final, if you look at it, the final hit is actually, the final hit is on this carbon. So this carbon no more plus, right? Actually, there's a no more plus on this carbon. Can you see that? Okay, so this is the arrow that we should be drawing. Okay, next question. We are actually breaking this bond, right? Oh, this is quite simple. This is just this bond being broken. All right, this bond is being broken. So you generally have to just draw an arrow here. Okay, so that's it. Okay, the next one, you must be able to tell that this bond was being broken. All right, and this bond is being formed. So I'll draw this way. So it essentially, the electrons go to the Br, and then the lone pair O, right? This lone pair will become a bond pair. So you have to attack this carbon. Okay, so this is like your SN. It's like a SN2 mechanism, right? Right, so that's what you get. Okay, next one, you must be able to see that this bond was being broken. All right, and actually, this bond is broken, and you must see that this bond was formed. All right, and this bond was also broken. Okay. So I'll say this. So this bond pair. Okay, so you must observe this bond pair will go to the D. All right, this bond pair will become this bond pair. And the next part is this, the electrons here, over here, the DBr bond, the electrons will go to the Br. So the only parts that will change in the charges, right, if you can see, the only parts that can change the charges is the Br, the final head, and the initial tail. All right, so that's why you can see there's a plus here and there's a minus over here. Okay, last few, right? Let's run through the last few. Okay, this question, I guess you can see that what is being formed. All right, this one actually only this bond is being formed. You see that this bond is being formed. So all you need to do is the lone pair on the Br will attack this carbon. Okay, yeah. All right, so that's where you can see the changes in the charges. So this lone pair become a bond pair. Okay, next one. Okay, next one, you can see that what bond was being formed. This bond is being formed. All right, and this bond is being broken. All right, so let's see. And then this bond is another green bond here. This one here is actually attached to a carbon. So I guess you're going to draw this. Okay, so this is like your carbonyl nucleophile addition kind of mechanism. Yeah. So last one, the lone pair will attack this H. Okay, so I think these are quite common. Okay, this one you must be able to see that for the next one, which bond is being formed. I can see that this bond is being formed. Okay, this bond I just highlighted is being formed, and I hope you can tell that this bond is being broken. Right, so actually the lone pair O will attack this carbon at the H. All right, and it's a nuclear. okay, and the electrons here will go to the O. Okay, with electrons, so you get O minus. Okay, so you need to know where are the bonds that are being formed and where are the bonds being broken. So that's very critical in order to do questions. Okay, next one. You can see over here, this bond is being broken, this bond is being formed, and this bond also being broken. All right, so I'm just going to draw now. This bond pair become a bond pair, but now bond to the Br. Okay, and then electrons from here goes to the Cl. Can you see that? So yeah, in fact, this one is almost the same. Oh yeah, this it looks pretty similar, right? 10 and 6. Okay, 10 and 6, they look really similar. Okay, and but there's also one more last step. Okay, the Cl minus, right? The Cl minus, um, this is the lone pair here. Okay, the lone pair here will join to the carbon. Okay, so you form this bond. Okay, last one. Okay, Et actually is just ethyl group lah. Okay, Et is just ethyl group. So you need to see that this bond was being formed, while this bond was being broken. All right, and I think there's a bond over here. This nitrogen, right? This nitrogen is attached to a H now, right? So in fact, this bond is also being formed. Okay. So how does it work? Okay, so I'm going to draw it out now. You can see Br minus, so I guess there'll be a electrons going there, all right? Then you're going to kick out, you notice over here, right, there's actually two H's. So this bond is actually being broken. I should have highlighted just now. Okay, this bond is actually being broken, right? It's being broken. So the electrons actually goes over here, right? Sorry. Okay, the electrons actually goes to here. Okay, so it forms a pi bond. Okay, it forms a pi bond. And now the NH bond, right? So the lone pair N will go to the H. Alright. So where are the change in the formal charges? You realize the change in the formal charges only happens on the Br and the N. Okay? So that's why you notice there's a plus on the N and a minus on the Br. Alright? So that gives you a good idea of how these questions are done. Okay, I hope you enjoyed this session of learning curly arrows in a more detailed manner.